Hi everybody, I'm going to talk to you about Dalton's Law and just go through the problems that you'll see in section 4G. So all Dalton's Law says is that the total pressure of a gas is equal to the partial pressures of all the gases in that container. So if you work through problem number 1, it says a sample of exhaled air from the lungs contains 4 gases with the following partial pressures. And then I tell you what all of those partial pressures are. If I ask you for the total pressure of the sample, all you need to do is add together the sum of all the partial pressures I give you. So nitrogen's partial pressure is 563 millimeters of mercury. Oxygen's partial pressure is 118. Carbon dioxide is 30. And water is 50. So the total pressure is just the sum of all these pressures added together, which gives you a total of 761 millimeters of mercury. So in the second problem, it says carbon dioxide is added to a cylinder containing 2.5 atmospheres of oxygen, giving a total pressure of 4 atmospheres of gas. So I just set up this formula right here that said the total pressure is the sum of the oxygen and the CO2. Now I'm just going to put in some numbers. I know that the total pressure is 4.0 atmospheres. And I know that the partial pressure of the oxygen is 2.5 atmospheres. And I don't know the partial pressure of the CO2, so I'll just leave that as PCO2, or X. So really, you're just solving for X. I'm going to subtract 2.5 from both sides, minus 2.5. And so the pressure of the CO2 is going to equal to 1.5 atm. So that's part of the answer. The other part of the question was, what's the partial pressure of oxygen? But that was just given to us right here, so we didn't really need to do anything to find that. All right, so this is problem number 3. It says air is a mixture of 21% oxygen, 78% nitrogen, and 1% argon by volume. What's the partial pressure of each gas at sea level where the total pressure is 760 millimeters of mercury? So here's what I did. To find the pressure of the oxygen, I took that 21%, but notice how I wrote it as a decimal, and I just multiplied by the total pressure, which was 760, and that gives me the pressure of the oxygen as 160. I did the same thing with the pressure of the nitrogen. Notice how I took 78%, but I divided it by 100 to write it as a decimal. Multiplied by the total pressure, and that gives me the pressure of the nitrogen. And for the argon, I'm going to take 1%, which would be 0.01 times 760, and that's going to give me a pressure of 8 millimeters of mercury for the partial pressure of the argon. Okay, if you read the last question, number 4 on 4G, it's talking about a gas being collected over water in the lab. So I tried to recreate that picture here. And basically what's happening is in this jar right here, you're producing some oxygen gas, which is bubbling and going through this tube, and then is bubbling through water until it starts to fill up a container with gas, and then the water level continuously goes down. What's important to know is that this pressure inside this container of the gas that's collected isn't pure oxygen. It's a mixture of oxygen and water together. So if you want to know just the pressure of the oxygen, you have to subtract out the pressure of the water. So the formula you're going to use is this. The total gas pressure is going to be equal to the pressure of the oxygen plus the pressure of the water. And it tells us in here that the total pressure is 760 millimeters of mercury. So I'll put that here. We don't know the pressure of the oxygen, so I'll just leave that as PO2. To get the pressure of the water, notice that it's collected at 23 degrees Celsius. If you flip to the next page, you'll see on the next page a chart that tells you the vapor pressure of water at certain temperatures. And at 23 degrees Celsius, the vapor pressure of water is 21.1. But you're going to have to look on the table on the next page for that. So I'll put 21.1 here, millimeters of mercury. And then you're just solving for X. You're just solving for the pressure of the oxygen. And so that's going to give you 746.9 millimeters of mercury. Oops, sorry about that. So it goes without saying that the pressure units that you use in all these problems have to be consistent. So if you're not in all millimeters of mercury or not all in kilopascals, you're going to have to get to one unit or the other. I want you to work on the 4G problems, the 4G Dalton's Law partial pressure worksheet. It should be on page 27 and 28, and the answers are at the bottom of page 28. That's it. Good luck, and hopefully I'll see you tomorrow.